Welcome today to our talk about global warming. And we're going to start out today with a global warming poem. And I'm not really sure who the author of the poem is. And I use this poem to demonstrate, a global warming concept. The topic's a hot one at that, said the first, putting on his straw hat. Evidence is forming that this global warming, and the sweat dribbled down his cravat. His opponent, unflappably cool, said, "Please don't take me for a fool. If the temperature's rising, it isn't surprising. It goes up, then goes down as a rule." "Sure, cycles exist," said the first, gulping water to stave off his thirst. "But our excess pollution's a new contribution. For this reason, I fear for the worst." Put all your worries on ice," said the other, tossing some dice. "I'd much rather wait and take my chances with fate. Till the bill is due, why pay the price?" The outcome, my friend, is up to you to find out which side is true. Before more time passes, analyze all the gases and help figure out what to do. Great poem, isn't it? Let's take a back slides and let's start over. So here we are. It says the topic's a hot one at that. Get it? Global warming, a hot one at that. So two people are talking. The first person here, what kind of visual evidence, when you read this, what kind of clues do you get? What kind of visual clues do you get? Putting on a straw hat, the sweat dribbled down his cravat. So you get sweat dribbling, a straw hat. You kind of have the imagery of an older person just profusely sweating, which would go along with the imagery of global warming. And his opponent, unflappably cool, so he's talking to someone else. "Please don't take me for a fool. If the temperature's rising, it isn't surprising. It goes up, then goes down as a rule." So the second person says, "Hey, chill out. Don't worry about it. Temperature, it goes up, it goes down. We know it was once warmer when the dinosaurs roamed the earth, and it's cooler now. So temperature goes up, it goes down, it goes up, it goes down. Just don't worry about it. That's just the way it is." But the first person says, "Yeah, cycles do exist." And again, you get that imagery here, gulping water to stave off his thirst. But person one talks about a new contribution, which is our excess pollution. And for this reason, that first person fears for the worst. We've never had that before. And the first person basically says, chill out. Put all your worries on ice. If you're going to put them on ice, chill out. And he said he was tossing some dice. In other words, he's basically willing to gamble. And he says, "I'd much rather wait, take my chances with fate till the bill's due." This always kind of reminds me of a credit card. A lot of times we'll go out and we'll buy this, we'll buy that. We don't have to worry about the price. We don't have to worry about not having enough money because we can put it on a credit bill. And why worry? Until we get that bill at the end of the month, we have nothing to worry about. Unfortunately, what happens when the bill does come due, if it comes due? So here's the of this whole unit. The outcome, my friend, is up to you to find out which side is more true. Before more time passes, analyze all the gases and help figure out what to do. I'm not going to tell you if global warming is existing or not. Or at least I'm not going to tell you why it's existing. Because no one really knows 100% for sure. It's up to you to analyze all the gases and help figure out what to do. So let's get some background information. Let's look at this cartoon. On the top it says, so these scientists did this experiment that if you drop a frog into boiling water, he jumps out. But if you put him in warm water and heat it slowly, he just swims around until he's cooked. What's the point of that experiment? Beats me. Scientists, go figure. Probably the same ones studying global warming. Look what they're in. They're actually in a large pot of boiling water. So the imagery here, the whole gist of it, is are we in a pot of boiling water here on our planet? Is it just slowly warming and we're not really thinking about it much like a frog? And like a frog, once it starts to boil, it's too late. The frog's cooked. Are we going to be cooked? So let's start taking a look at global warming versus climate change. Things generally associated with global warming. Population growth, reaching 7 billion on our planet. Energy use, and we just got done with an entire unit on energy. Land practices, how do we use our land? And industrial activities. So global warming is considered to be an enhanced greenhouse effect. Most but not all scientists influenced to be a major contributor to global warming. And this is person one in a poem. So a lot of scientists think that we as humans are major contributors. However, here are some things associated with climate change. Solar variability, and that's the sun moving further away, maybe the sun wobbling, or the solar variability, more the alignment of or I should say, how the sun circulates around the Earth, the orbit, that's the word I'm looking for, might become slightly more elliptical. Volcanic activity, biological evolution, El Nino, things like that we can't change. And that's person 2 in the poem. We have no control over that. And there's also scientists that will sit there and say, well, these are the things that are changing global warming. It's a natural process. We have nothing to do with it. While we do know that our planet is unique, we know that we have an atmosphere, we have water, we have soil. And all these, when you put them together, they are capable of providing what we need to survive here on our planet. And the daily needs of more than 6 billion people continuously stress the limits and balances of the Earth. Now that 6 billion probably can be changed over now. So when we look at our planet, it's kind of like Goldilocks and the 3 bears. Remember that story? One bed was too soft, one was too hard, one was just right. One porridge was too hot, one porridge was too cold, one was just right. That's kind of like our planet. We got one planet that's too hot. We got one planet on the other side that's too cold. We've got one planet with too thick of an atmosphere. We got one planet with virtually no atmosphere. And then in the middle, we have planet Earth, which has obviously a good atmosphere for us. So the Earth's climate is the complex system that ties together the atmosphere, oceans, and land surfaces. A lot of times when we think of climate, we think of the weather, we think of the atmosphere. We don't often think about how the oceans and the land tie into that, but they do. Now, most scientists are changing our climate. However, remember, I did say many scientists, or I actually said most scientists, but many do. But there are scientists who do not. And that's why you need to help figure out what to do, and you need to decide for yourself. So, is our climate changing? Well, let's talk about climate. Does one extreme summer indicate climate change? So if we have a really hot summer this summer, does that mean the climate's changing? Well, no. What we have to do is we have to compare measurements taken over many years, and then we can start to get a sense if the climate's changing. For example, the hottest 10 years of the past 100 years have all taken place since 1987. And that might start to, kind of lead you towards climate change. But, again, you need lots of evidence to help support that. So what is climate? Climate describes the weather patterns over a long period of time. So just one hot summer is not going to impact climate. It takes a much longer period of time. So how do scientists study the past climates? Well, first of all, we can take a look at written weather records. Now, these only exist for about 150 years or so, or at least really good weather records. What else can we do? Well, we can also look to the environment, actually provide us with many clues that go back thousands of years. For example, ice cores. If you look at this ice sample, and this is an ice core, they took, basically drill down and they take a long tube of ice out of the glaciers. And ice in polar regions contain the tiny air bubbles. So what scientists will do is they'll actually go into those tiny air bubbles and pull out that air and see what was in the air. And one of the things they look for is the concentration of CO2. Because typically if there's more CO2 in the atmosphere, carbon dioxide, the weather was, or the climate was, hotter. We can also take a look at tree rings. How many of you have ever seen a tree ring? Well, we know that the tree rings, if it's a larger ring, it meant there was a good growth. So one would think that there was plenty of moisture, plenty of sunlight. It was, warm. It wasn't cold. But if the tree ring is really small, it's the opposite. It was probably cold. It was probably dry. And there wasn't very good growing seasons. So we can, infer what the weather or the climate was like during those times. We can take a look at fossils. The bones of long dead animals indicate which species live in areas. If there's a species that is living further north that typically would be further south, that would indicate, well, at one time it was probably warmer where that location was. Sediment cores. After determining the age of the sediment layer, scientists can actually study where plants were growing when the sediments were deposited. We're actually going to do something similar to this. We're going to do a paleobotany lab where we're going to be taking a look at pollen, and we're going to use the pollen to identify the plants. And we're going to see what kind of plants were growing when and where. For example, if you have, say, a cactus pollen, and you have that cactus growing in an area where there are no cactus today, or they weren't growing, but you find a pollen, say in the bottom of a lake sample that we took. much further north than where it is today, it would lead someone to believe that, well, at one point in time, that area was warmer. Likewise, if you go into the middle of the desert and you take a core sample and you find deciduous trees, it would probably lead scientists to believe that at one point in time it was much moister than it was today, and probably not as hot. We can also take a look at archaeological records, and we can use those to help date, not necessarily date, but figure out what the climate was at certain time periods in the Earth's history. So that concludes part 1 of global warming. Thank you.